Welcome to a video where we will look at an application of polynomials. In this video, we will learn how to determine the maximum profit using Desmos. Let's get started. Suppose a company's revenue function is given by R of Q is equal to negative Q cubed plus 370 Q squared, and its cost function is given by C of Q equals 140 plus 20Q, where Q is in thousands of units sold and produced, and R of Q and C of Q are in terms of total dollars of revenue and cost, respectively. Let's determine the profit function. Since the profit is always the revenue minus cost, to find the profit function, we want to take the revenue function and subtract the cost function. So we'll take negative Q cubed plus 370 Q squared, and we need to subtract off 140 plus 20Q. Distributing the negative to 140 and 20Q, we get negative Q cubed plus 370 Q squared minus 140 minus 20Q. So in other words, our profit function is equal to negative Q cubed plus 370Q squared minus 20Q minus 140. Now that we have our profit function in terms of total dollars, P of Q, which we saw is negative Q cubed plus 370Q squared minus 20Q minus 140, where Q is measured in thousands of units sold or produced, let's determine the number of units that need to be sold to maximize profit. And then let's also maximize the profit. Before we do this, let's review. When we were looking at quadratic functions, we found out that the maximum or minimum value occurs at the vertex. So to locate the vertex of a parabola or a quadratic function, you could use the formula x is equal to negative b over 2a, and then to find the y-coordinate of the vertex, you would plug that value back into the function. For general polynomials, determining the maximum or minimum using the formula utilizes techniques from calculus. In this video, we'll look at how we can find the maximum or minimum values graphically. So let's take our profit function and go over to Desmos to see how we can find the number of units that need to be sold to maximize profit. From the website desmos.com, either click the button to open the graphing calculator, or from the Math Tools menu, select the graphing calculator. On the left-hand side, let's enter our function into the first cell. Once you enter the function into the first cell, you'll notice on the graphing window that you cannot see the entire function. So you can either use the mouse to zoom in and out, or on the left-hand side, you can use the zoom in and zoom out buttons. If you use the mouse to zoom out, you notice that this graph is pretty large. So I'm going to click on the wrench to adjust the graph settings manually. I'm going to set the minimum x-axis value at negative 100 and the maximum at 400. And for the y-axis, I'm also going to set the y minimum to negative 1000 and the y maximum to 10 million. Now I can see the graph, but I want to just move it up. So I'm just using my mouse to move the graph around. You'll notice since the y values are fairly large, these are all in the millions, that Desmos has converted them to scientific notation for us. To find the maximum value, click on the graph to reveal the points of interest. These are usually highlighted in gray. Click on the point again to reveal the coordinates. I now can see the coordinates of the maximum value. So the maximum will occur when Q is 246.64. There's two ways you could find the maximum profit for this polynomial. The maximum profit will be the y-coordinate of the relative maximum here, so 7.4991 times 10 to the 6th. You can also find the maximum profit by evaluating the polynomial for that value of q where the maximum occurs. So let's evaluate p at the value of q, 246.64. And that gives us a profit of $7,499,075.09. You might be wondering, why didn't I consider values of q or values of x that were over here on the left-hand side? Because clearly the profit function is higher on that side. While the polynomial is defined for those values, it doesn't make sense in terms of this setting. So if we're talking about Q representing the demand or the number of items sold, then Q is going to have to be greater than or equal to 0. So while this is part of the polynomial, it doesn't make sense in this application problem. So to summarize, we found that when demand is 246,640 items, or in other words, when Q was 246.64, profit will be maximized. When profit is maximized, it would be $7,499,075.09. That's it for this video. Thanks for watching.